Malaysia Green Building Council, also known as Malaysia GBC, is an organization that promotes green building programs, technologies, and design practices, aims to make Malaysia an eco-friendly and sustainability place on Earth. Malaysia GBC was founded in May 2009 by a group of passionate building consultants, academia, and representatives. Even since Malaysia's building has increased, the efficiency of resources used in each building was built with green in mind. Malaysia GBC is also supported and associated with most of the top industry institutions. In the year 2015, Malaysia GBC became an established member of the World Green Building Council and known to be the only organization in Malaysia to be supported by the World GBC. Malaysia GBC continues to be the platform that networks, promotes, educates, and most importantly, develops the sustainable, built into the land of Malaysia. With much more passionate industry professionals, we can make Malaysia a greener and better place on Earth.
Hi, good evening, ladies and gentlemen. My name is James, the Council Member of Malaysia GBC. It is a pleasure to welcome all to attend today's session of IGM Malaysia GBC webinar. I will be the moderator for today. Ladies and gentlemen, for your information, this webinar will be recorded and you are able to review it in the IGM website later. I wish to thank you for all spending your precious time to attend this special presentation and innovative engineering technology towards a clean and sustainable environment. In this webinar, we will talk about automated waste collection system, or known as AWCS, a pneumatic waste conveying system transport domestic solid waste through underground pipes at a high speed from the waste chutes into a sealed container. The explorations of the AWCS today will be focused on how AWCS can be adopted for waste removal into different development types. Also exploring how AWCS could contribute into sustainability, community, and environment. We will also discuss what is the challenges, difficulties AWCS encountering during the installation and implementation. Ladies and gentlemen, it is my pleasure to introduce our distinguished speaker, Engineer Chia Tian Teck, the Group Chief Executive Officer of Stream Group Sdn Bhd, Malaysia's first central vacuum system and automated waste collection system. Currently, Stream Group has serving more than 160 projects globally. With his 25 years of experience in waste management and mechanical engineering, Engineer Chia Tian Teck, no doubt, is the right person to share his experience in our webinar today. Please feel free to type in the questions that you would like to ask the speaker, and we will address it during the Q&A sessions. With this, without further ado, I hand over the floor to Engineer Chia. Thank you, Engineer Chia.
Thank you, James. Good afternoon, ladies and gentlemen. My name is Chia from Stream Environment and Stream Group. First of all, I would like to thank Malaysia GBC for giving me this opportunity to introduce the product, the technology today in this IGM event. My topic today, I will be focusing on a vacuum technology. Let me see. Where's my, okay. My topic today, I'll be focusing on a vacuum technology designed to handle solid waste, which is commonly known as automated waste collection system, or in some countries, it is more known as pneumatic waste collection systems. Let me see how to share the screen here, because
I think the screen is not shared. Engineer Shah.
Yeah. Let me share the screen. Sorry, they are big, a big.
Okay, good.
I think
We
we are
can
here.
see the screen right now.
Yeah, yeah. So I will start my presentation today with introduction to automated waste collection systems, AWCS in short form, and then why automated waste collection systems or AWCS. And then I'll share with you some mega cities and countries with AWCS in place. And finally, I will share with you some case studies for completed projects. So what is automated waste collection system, ladies and gentlemen? AWCS can be represented by this illustration here. So for high-rise building, example, residential tower or office towers, we will have the chute or the floor point that we installed to every floor to allow the residents or the tenants to dispose of their garbage in the same floor. And then we have the storage station at the bottom of the chute to collect the garbage, the discharge valve, the air intake valve, the waste transport pipe. So this waste transport can be underground if the waste bin center is located at a standalone and located further away from the development. It can be also, bin center can be also located in that particular development, within that particular development, within the buildings. So if the bin center is located within the building, then the pipe can be located, at a high level of the certain floor, podium, or maybe a basement car park. Another important component in this system is the vacuum plant, which is located in the bin center. And then, of course, the sealed container. Today, I'm going to introduce to you three common systems available in the market. The first two systems are very common, and this gravity vacuum system is the first system that I would like to introduce to you. And this system has been in the market for at least 50 years. In Malaysia, this system, the first system was installed in Malaysia about 20 years ago. Right. So how does this system work? This system, gravity vacuum system, are usually recommended for residential building and office towers. So the residents or the cleaners or the tenants in this building will have to dispose of the garbage. The hopper door located at every floor. So the waste will be stored at the bottom of the chute. When it reaches the level sensor, the system the is full, and then the storage system, the vacuum valve had to discharge the garbage to container. So the vacuum pump start running and then creating a vacuum inside a pipeline. The waste will be discharged, will be transported to airtight container, and the air will go through a vacuum pump and go to air filtration system before it is discharged to the ambient, to the surrounding environment. Take note of the airspeed at item 4 here. The airspeed inside the pipeline range from 20 meters per second to 25 meters per second. So this is equivalent to about 70 to 80 kilometers per hour. So this is a photo and also a drawing showing at the bottom of the chute. So at the bottom of the chute, we have the chute interface, the blue color part, at the photo on top, and then the storage section, the stainless steel storage sections. And then at the bottom, the blue color part component of discharge valve. So this discharge valve is a component that isolates the vacuum line from the gravity chute. And the hopper door, as shown from the left top corner, the hopper door is a volumetric control hopper door, limiting the size of the garbage that you can throw inside. There's a purpose of why we have to install a volumetric control hopper door over here. I will explain to you later, probably through the Q&A sessions. The second system is usually known as full vacuum systems. Full vacuum systems are key operated, so the user has to be trained on how to use the systems. And these systems are usually recommended in commercial buildings like shopping malls, hospitals, and airports. So how does it work? The cleaner or the tenant have to bring along with a key to operate the systems. So when applying the key and then turn on the systems, and then system will be running, and then the waste will be sucked all the way to the airtight container, to the bin center, and then again, the air will go through the same process, go through the air filtration system and discharge to the surrounding environment. So this is the photo and drawing showing how does it look like, the throw station, the outer door and the inner door. And then on top of the station, usually you can see the air intake valve. And then this station will connect to the waste transport pipe, which is connected all the way to the bin center, to the container in the bin center. Right, the third system is called a vacuum shuttle system or waste shuttle systems. Over past 20, 30 years in the market, and from the data collected from the government agencies and also institutions, we notice in the solid waste stream, 50% of the waste are wet organic waste. Wet organic waste, when you mix with the dry waste, which are usually recyclable, the whole waste, the entire waste that you collected will most likely end up in the landfill, because the dry waste you will usually contaminated by the wet waste. So the first two systems that I introduced just now, the minimum pipe size is 400 mm diameter, 16 inches. So you can't, extend the pipe all the way to kitchen, because food waste are usually generated in kitchens, and you will end up in kitchen first before the user make it with the dry waste. But the shuttle system, the pipe size can be as small as 100 mm diameter, meaning I can extend this pipe all the way to kitchen's area, at the kitchen sink or somewhere within the kitchens. This provides convenience to the user to dispose of the wet organic waste localized, to prevent this wet waste from mixing with the dry waste. So by doing this, we do believe the wet waste, when you separate the wet waste, this wet waste, you can utilize it for something else. I'll explain later. And then the dry waste, you can send it to recovery center to recover all those recyclables and also reproduce for reuse. So how this system works, shuttle system? Such system, general concept usage is still the same, like gravity vacuum system. So the user will still have to dispose it into inlet, you stop that temporary. So when the storage is full, the waste will be sucked into the main pipe. Stored in the main pipe temporary. And then once all the waste are discharged to the main pipe, we will create a vacuum through a valve control in the waste transport pipe, and we introduce a positive pressure to push the shutter. So you can see the left corner, the shutter is moving. So the shutter actually is being pushed by the positive air pressure. And my apology, because the simulation here a bit, crumbled up, so not so clear here. But the waste one, the garbage pushed, once the shutter pushes the garbage into the container, we will introduce a vacuum to retract back the shutter to the original positions. This system consumes 80% less energy compared with the first two systems that that I mentioned just now. Right, so this system is second generation system. It's not so common at this moment because it's patented. So why AWCS, ladies and gentlemen? This is a common sight of the waste surrounding us. These photos are taken from some shopping malls, big shopping malls somewhere nearby, somewhere in Klang Valley areas. Some are taken from residential areas. So you can see this. When you look at the left center photos, can you imagine during raining times, what will happen to this garbage? The rainwater will wash into the drain. And from the drain, you go to a river, to the lake, and probably to a sea. You will end up having this situation here. Right? So this is not happening, and maybe it's happening in Malaysia, but this photo was taken in overseas. So I don't think we want to see this happening in Malaysia. Maybe it's already happening somewhere in Malaysia. And why this happened? These leakages, this issue here, the waste management issue that we are facing today, is not from the landfill, no? Landfill had their own problem, but the issue that we are facing today is from the waste source, the point the waste is generated before it reaches the disposal point. Along this way, along from between the generation point to the disposal point, there are so many leakages because of manual transfer, on-site segregations, and all this is not managed properly, or because of open bins. Remember sewage systems. We deviate a bit from the solid waste at this slide. Just remember sewage system, our toilet. Many years ago, this is how we handle our toilet waste, the sewage. So we have this uncle, this stocky, coming, every evening, usually evening, to collect, the sewage in the bucket and then transport it, put it on the truck and then transport it somewhere else, maybe for fertilizer or something else. So this was how we manage the sewage in the toilet. And then after 60s, we have septic tank, every houses. So this guy with the truck will come to the to the houses every 2 or 3 years maybe, and then collect the sewage from the septic tank and then bring it to the treatment plant. After 90s, all buildings today are all connected underground with the sewage piping network. Whatever business you do in toilet, one flush you don't see anymore. Everything is gone. So imagine this toilet in a shopping mall or in the conference hall. If this guy, you still have this guy coming here toilet to collect the sewage from the toilet, can you imagine what kind of mess are we in? Since human civilizations, human activities produce 2 types of waste. One is the sewage, the waste from our own body, the toilet waste, and the other one is a solid waste. Today, this guy is gone. We already have the system addressing the sewage. The changes our forefather made many decades ago allowed us to have this clean environment today. But today, the solid waste, we are still using the conventional way, the primitive way since many, many years ago. We are still using this method. Collecting the garbage from the open bins, which is equivalent to a bucket, in sewage systems. So solid waste management is still at the stage of bucket. Again, coming back to this lobby, looks very clean, very nice, looks very comfortable with aircon. You have this guy coming again to collect the sewage. You don't have this kind of environment today, So why are we doing this with the solid waste? I think this is very common. I think probably every one of you in this event will probably experience this. So conventional waste management. These pictures here, I think is very common for every one of you. You have a spillage, you have pest issue over here, you have the traffic issue here, you have leachate issue here, manual transport. So by putting in AWCS system, from the point you throw garbage, you don't see garbage anymore. It is similar to the sewage system. One flush, you don't see anymore. Whatever business you do in the toilet, it is gone. So similarly, we are trying to do this. We are trying to copy the sewage system to apply it into the solid waste now by using these automated waste collection systems. So today, garbage collections, door to door, house to house, curbside collections, we can actually change it with this infrastructure for solid waste. We have done this for sewage systems. And it is possible for us to change the way we handle solid waste or the garbage. If today we can separate the wet waste from the dry waste stream through the sealed system pipe infrastructure, the wet waste can be transported to an aerobic digestion plant, and you can convert to energy by converting the food waste to methane and then convert it to electricity. And then the compost, the residue can be used as compost or soil enhancer. And then the dry waste will be transported to the recovery facility. With this in mind, if we are able to achieve this, then the zero waste that we have been talking about in the past few decades can be achieved. Okay, advantages and disadvantages of AWCS. AWCS will require less storage space. Why it requires less storage space? Imagine the conventional system, the current way of handling garbage. Every block, the architect had to design a refuge chamber to store garbage. And every floor, you will have the refuse room to at least house the 240 liters mobile green bins. So this room usually 2 meter by 2 meter, and you have to provide this every floor. By putting AWCS, what you need to do is to install a 500 mm diameter chute, and you don't even need a storage every floor actually, because you don't require that, because by the user throwing the garbage into the chute, it will drop by gravity, and it will be stored at the bottom of the chute. And once it is full at the storage sessions, the vacuum system will suck it away and bring it to the bin center. And then it will also reduce the traffic. Look at the illustration at the right-hand side here. So door-to-door curbside collection, the garbage truck have to move around to collect garbage. Whereas in AWCS system, all the garbage generated in all the building can be channeled, can be transported to one centralized location, and the garbage truck just need to come to this location to take the garbage away. Bear in mind, empty truck, the empty garbage truck that you usually see collecting garbage from the house, the empty truck weight usually 7 to 8 tons. So can you imagine the fossil fuel that the truck burn to move this steel, 7 to 8 tons steel? It's always energy, and it really increase the carbon footprint. And then third, lowest carbon footprint. Why I say so again? Imagine for a high-rise residential building, how do we collect the garbage at this moment conventional way? The cleaner, actually using cleaner will have to go probably half day in the morning. They have to go every floor to collect the mobile bin and then bring it to the service lift or sometimes passenger lift, and then go down and to the ground floor and then push the bin all the way to bin center and then dispose the garbage, empty the garbage inside, wash, clean the bin, and then bring back the empty bin and go into the service lift and go up again. Try to imagine vertical transportations of this garbage. It consumes a lot of energy actually using the lift. So by using AWCS, by us installing the chute, the vertical transportation of the garbage is by gravity now. Gravity doesn't consume energy at all. So vertical transportations, imagine how many thousands of blocks, buildings in Klang Valley area alone. What kind of amount of energy we could save from putting the chute and connect to vacuum systems. Of course, the system, as mentioned just now, is a sealed environment, it's a sealed system, because if the system, the pipe leaks, then the system couldn't perform, couldn't run. Of course, with sealed system, you don't have pests. The pests have no area, to access to the food. Reduce labor, so you don't require a cleaner to collect garbage now. So the tenants or the user or the resident have to throw the garbage themselves. Maybe you still need a cleaner to clean the common area. So probably you can cut the labor to half. Low cost and low maintenance hook lift truck. This is good for local council and also the service provider. Garbage truck with hydraulic system in the truck, the maintenance costs are very high. So our system here, this automated waste collection system require a hook lift truck. The truck that can collect the open bins in the construction site is the same truck that can collect these containers. Of course, the last one is eliminate security threats. Unfortunately, I can only find one cons here, disadvantages here is actually higher capex. The capital investment costs are much higher compared to conventional system. But you try to imagine back again toilet systems. If today we put bucket in every houses, in every toilet, it doesn't cost us much. Maybe one house maybe costs us $50. But today, by us putting a piping system in building, connecting all the toilet with the toilet bowls, everything, toilet bowl alone maybe will cost us $500 already. So the entire building, the toilet system will probably cost more than 10 million. So it's the same thing here. You know, why today nobody questions the amount of money we spend on toilet systems? It's become a norm now. But unfortunately, this AWCS is still new. And this is why we are here to try to introduce this product to our own Malaysians. I will show you to you why own Malaysians, because we have done a lot of projects overseas. And I think it's, as a Malaysian-based company, I think it's time to introduce this to us ourselves in Malaysia. Out there in Singapore, our neighbor, Singapore is the first country in the world making this AWCS regulated, a mandatory requirement for all HDB, the government housing development, and any private development having more than 500 dwelling units or apartment units. It is mandatory to have these AWCS systems. Singapore is the first country regulated this system in all their development, residential development, meeting this criteria. And Singapore is the first country having a standard for AWCS, a standard with Singapore standard SS642. Coming back to Malaysia, this AWCS is allowed and is actually approved in SW Corp guideline, their handbook, under section 7.5, GBI under section 6 innovations, Green IE section 5, and in Singapore, BCA Green Mark section 5 innovations. So look at these utilities: water, sewage, power supply, transportation, and city gas. These are all infrastructure now. Can you imagine today, the water supply, we are still using truck, or the sewage, we are still using truck to collect the sewage or supply the clean water. Can you imagine the city now full with congested or full with all the garbage, the water truck? The city can't move now and we can't expand. We can't accommodate more population in the city. So to allow us to expand and allow higher density of populations, everything has to turn into underground and with pipe infrastructures. Today, the issue that we are facing today with solid waste is also partly because we didn't change it to pipe infrastructure. So our aim today, introducing this product, this system here, the AWCS, is actually with the objective, one day, all our building will be connected by underground pipe for solid waste, to collect solid waste. And probably one day, we can separate with two pipes, collecting the wet waste and the dry waste, and send it straight away to an aerobic digestion plant or to the material recovery center. We do not inherit earth from our ancestors. We borrow it from our children. Gentlemen, ladies and gentlemen, what is sustainability? Layman terms, for a layman like me, sustainability is when I take over this environment from my grandfather, I will have to hand it over to my grandchildren in the same, at least in the same environment. So we have to ask ourselves today, we have been talking about sustainability today. So are we able to hand over this environment, the earth, to our grandchildren in the same situations without garbage or with lesser garbage when the time when we take over from our grandfather? This is something that we have to ask ourselves. All right, so these sections I will share with you. Just a short slide over here. Few cities that have been using this system with AWCS. AWCS have been quite widely, commonly implemented in Europe. Most of European countries and cities have been using these systems. They replace the underground sewage pipe, with, refurbish, and then they replace this pipe with the waste pipes, and then use it for waste transportations. And then we also have in Middle East, also in Australia, China, and actually in Malaysia alone, we also have at least about 70 over projects in Malaysia. So we have completed about almost 60 projects in Malaysia, serving about probably 200 buildings. And then we also have about 20 over projects under construction now in Malaysia, right? So it's not new actually. All right, the last session, I'll be sharing with you some case studies over here. The first project in Malaysia, location in Johor. So this is a small residential building with about 1,100 apartment units with a waste capacity of 2.8 tons per day. So you can see this pink color, these are the indicating the refuse chute to every floor, to top floor of the building, of the towers. So we have 3 towers over here. Every floor, we have this hopper door in the refuse rooms with a chute. At the bottom of the chute, we will install this chute interfacing and also the charge valve and the storage section. All these are sealed. And then we have a full vacuum stations for the retails. Another full vacuum for the retails. This is the ground floor layout plan. So the waste pipe is actually connecting to all the 3 towers and it's running at high level of the ground floor. And you can see at the top right corner, the bin center is located at the top right corner. And this is the bin center. For 1,100 units, a small bin center, 6 meter by 8 meter and height of 5 meter. To cater for entire development, 1,100 units. Second case study, also in Johor Bahru. This is the government administrative center in Kota Iskandar. This red color area is Kota Iskandar here. This entire area is served by one system, one bin center. So you can see this satellite photo. The bin center is located at this circle. The furthest point from this drawing, the pink color line is actually the underground waste transport pipe. And the furthest station is about, from the bin center, is located about 1.1 kilometer away, located somewhere near the Chief Minister office. This is the furthest point is located at Chief Minister, somewhere near the Chief Minister office. And the bin center is at the left bottom corner. So these are some photos for the disposal stations, the outdoor load stations, and the discharge valve and the storage section at the bottom of the chute. So this is the bin center layout with a capacity of 30 tons per day. So this bin center can manage the waste generated in the entire area with a capacity of 30 tons per day. This is the vacuum exhauster. Second case, the third case study in Singapore, in somewhere near Tampines, you are familiar with Singapore, and serving about 2,600 apartment units with waste capacity of 8 tons per day. This is the general layout of the buildings, the residential blocks. And the bin center is at the right side here. So from this layout plan, the blue color is the underground waste transport pipe. The bin center is represented by this yellow box. So all the buildings, 32 blocks, are all connected by underground pipe to one bin center located at the left-hand side of this layout plan. So every block will have a chute and discharge valve serving every block and every chute. And then there are also outdoor load station, outdoor disposal unit serving the ground floor and also the public area. And this is the throw station. The left photo is actually the every floor in the residential block. So there are two fractions over here. The system is designed to handle two types of waste, two fractions of waste, the mixed recyclables and the non-recyclables. So the foot pedal type is actually dedicated for non-recyclable, and this hand operated is for recyclable. And this is the outdoor road stations, recyclables and general waste. This is very common in Singapore now. And these are photos, for at the bottom of the chute, the discharge valve, and you can see the black color pipe. This is the waste transfer pipe. And then this is a photo showing the construction stage of the bin center. And this is the completed installations. So you can see the right corner, the vacuum pump, high suction centrifugal fan. And then there are 3 containers over here. So 2 containers for non-recyclables and 1 container for mixed recyclables. So they don't have on-site segregations. So all the mixed recyclable will be conveyed, transported to airtight container dedicated for mixed recyclable. And the service provider will collect this container, will come actually with the hook lift truck, collect this container, and they'll bring this mixed recyclable to the recovery center to sort out all kind of waste. And then the non-recyclable will go straight to incineration plant. The 4th case study is a project in Abu Dhabi. This is so far the biggest system in the world in a single contract. You can see this red color area here. This whole area, 12 kilometers, is designed with AWCS in place. And we have completed the first phase, the eastern precinct, about 5.5 kilometers. And then we also are in the midst of installing the underground pipe for the center portion here since 2005. So this is the eastern precinct, about 5.5 kilometers from one end to an end. So if you are familiar with this UAE, towards the right-hand side of the highway is towards Dubai direction, and then left-hand side is actually towards Abu Dhabi directions. So this entire stretch of development, we have already installed about 16,000 meters of underground pipe, getting ready to be connected to about 200 plots, sub-plots in this area. So you can see this different color here is indicating different plots, different development. So when the developer, sub-developer come in to this particular piece of land to develop, they will have to connect the building chute and also the pipe, waste transfer pipe to the infrastructure. You can see these photos, all these buildings are completed. And this photo was taken about at least 8 years ago. So this area about 50% developed now. So we expect the entire development will be completed with all the building built in next 10 years. This is a photo showing the underground pipe installations, the waste transfer pipe. And then you can see, this photo here, you can see my cursor moving. So this is the discharge valve with the storage sections and control system, and the waste transfer pipe here, and the 2 fractions throw stations. These are the equipments in the bin center, the compactor, the vacuum exhauster and compactor and container, and the waste diverter and the bin center. So we have totally 5 bin center in this development, serving 200,000 populations. The last case study I would like to share with you is also in Abu Dhabi. The Al-Raha Beach I shared with you just now is at this corner, at the bottom right corner. So this is our Rim Island. This area here is also served by AWCS. You can see this Marina Square. So from this satellite picture, this entire area here of Marina Square, about 30 of our buildings, high-rise buildings, are served by one bin center, the orange color bin center, at this circle. The furthest point is located about 1.5 kilometers from the bin center. So this is the layout of the bin center. There are 6 containers inside. You can see these containers here. And the bin center It's located about 1.5 kilometer away from the furthest point. And the towers at the background are all connected with a chute all the way to the top floor, and then with underground pipe to this bin center. These are the equipments in the bin center. Vacuum exhauster, the compactor, and this is the compactor with conveyor. So with these configurations, the container one is full, the conveyor will shift the container to this side towards this side, and then the container at the back will take over the positions. So these are all done automatically by the computer. And lastly, I think I have to take this opportunity to introduce my company for a short while. So to share with you our presence here, we are actually a Malaysian-based company, and we have a lot of, actually we are one of the major players in Singapore and Middle East. And we also have our local partner in Australia, China, and UAE, and also Qatar, India. And we also have some project completed in Hong Kong and Taiwan. All right, so I end my presentation here, my topic today here. Thank you so much for your attention. Back to you, James.
Thank you, Engineer Chia, for such a insightful of the AWCS automated waste collection system. It is clearly that that the automated waste collection system is one of the sustainability ways in waste management, whereby all the waste which I can see here, whereby from the domestic or residentials could be collected in one central waste station. I think this could be cut down the cross-contaminations between the user and the waste collector. Okay, I received some questions raised by the audience. Let's see from here. I think questions number 1. Hang on. Does the AWCS chute automatically select the waste? I was wondering if pests could simply enter and exit the chute, since we would need to wait until the system is full before it is sent to the final facility. Engineer Chia?
Okay, the question is related to the chute, right, and the pest, right?
Yeah,
the chute.
And the chute and the pest.
Okay, it's quite common, basically, when the user and the residents store the garbage at their home, at their house. So there could be a possibility that, example, a cockroach will go inside, the garbage bag, and when the user throw it into a chute, the cockroach will stay, come out and then stay in the chute. But the hopper door is actually magnetic, actually with a magnetic strip. So usually this cockroach couldn't come out. So if in case actually they were actually in the storage section, when the system discharge, the waste and sort of pests will be all sucked into the waste transport pipe. And this pests actually will be usually disintegrated, in the pipe, because traveling at a speed of about 80 km per hour. Even if this pests survived in the waste transport pipe, they went into a container. The container is actually airtight and watertight. So they couldn't come out actually. So this community will just stay probably in the pipe. But usually they can't stay in the pipe because it's under a high vacuum. So for them, it's a typhoon inside the pipe when the system is running. So as long as this pest doesn't come out, and then it won't actually create any environmental nuisance, to the environment. So I hope I answered these questions.
Yeah. Okay. Then we have the second questions regarding on how big is the size of the opening to the pipe, and can it fix a typical size of household garbage size? If the opening of the chute is too small, user might have difficulty to throw the waste through the pipe.
Okay, I think I understand, the situation actually that usually the user in Malaysia are facing, because usually the chute in Malaysia, chute is not common, because the conventional way of handling garbage in Malaysia are open bins, and we tend to, our mentality is actually we used to collect the garbage in very big bag. So we collect the whole day at the evening after dinner, then only we dispose of the garbage in the very big bag. So, but in other countries, like example in Singapore and Australia and some European country, it's very common. So they have this chute, every floor, and it's very common. They already used to it to dispose the garbage into the chute. So they know how to control, how to manage the size of the garbage to be disposed into the systems to the chute. So in Malaysia, our intention of providing this volumetric control hopper door, the opening is actually about 340 to 380, the opening size. It's big enough for the user to dispose of the garbage collected in like the example, those are hypermarket bag, like Giant, or those grocery bag. Those bag is good enough to be thrown into the systems. And we by limiting the size of garbage, we also encourage the user from throwing in the bigger waste like cardboard, polystyrene. These are usually recyclable. Today, our habit, we just try for convenience purpose, we just try to chuck everything and then throw it, and then the rest is not our business. So I think we have to do our part in actually segregating, the kind of waste, before we throw into systems. This system forcing the user, it kind of providing some inconvenience here, but it's forcing the user to start to segregate the bigger waste, and these are usually recyclables. Yeah, so I think over time, I think you have more people understanding why we have to introduce volume control hopper door here. And for your information, many years ago we have actually many years ago, probably 30 years ago in government flat, chute doesn't work because today chute is banned in Malaysia, So it's not common because it's banned, it's not allowed in Malaysia. Many years ago we screw up. What does it mean is we have a chute which is built by probably a brick wall, and then there's no volume control. Disposal door is as big as 600 by 600. People can throw in broken chair, pillow, mattress. It created a lot of issues. So and then fire, sometimes people, because of choking, sometimes people, burn it, to clear the blockage, this sort of thing, and then pass all this sort of thing, this issue over here. So that's why it was banned, because we didn't handle it, we didn't manage it or design it properly. So today, the gravity chute is allowed now. It is connected to AWCS system, and it's already allowed by SW Corp, the authority involved in managing the solid waste in Malaysia.
Okay, we also have another questions regarding the safety of the opening of the chute. So the audience is asking any safety features at the opening of the chute to prevent any accidents, such as like accidentally fall into the chute, like for a small kid size, body size.
Okay, good questions. All right, for gravity chute, just now I introduced two types of systems, a gravity chute and full vacuum systems. So gravity chute, the minimum requirement of the height of this hopper door must be minimum 1.1 meter from the finished floor level. So meaning any kids actually able to reach this level quite big enough, and they can't go into this through this volume control hopper door. So this prevent kids from accidentally drop inside the chute. If you install the chute at maybe 300 mm, just 1 feet from the floor level, then there's a possibility, a small kid, a baby, and then they open up and then they fall inside. So for gravity vacuum system, the door must be at least 1.1 meter from the finished floor level. It's one of the safety feature to prevent any accident from the small kids. So for full vacuum system, because the door, when you open up the door and when the inner door open, you can feel the suctions, vacuum suction. The bag will be sucked in. That's why, as I mentioned just now, for full vacuum system, the user, usually the cleaners, will be trained to use the system before we give them the key. Yeah, so I hope I answered these questions.
So actually the size, the height of it, the hopper opening will be actually limit the small kids to climb.
Yes.
So we have another question is from the audience is asking, what if the rubbish caught fire within the chute or waste collections? Is there any self-fire extinguishing system to curb the fire?
Okay, talking about fire protections the chute, one requirement here, the hopper door must be fire rated. So must be at least 1 hour fire rated. And this is complying to the Uniform Building by law in Malaysia. And for the chute, usually fire will happen at the bottom of the chute because this is the area that the garbage will be stored there temporarily before it discharged to the container. So if someone throw the cigarette butt, anything, caught fire, there should be actually, in Singapore, we have the sprinkler point. If the development and HDB, they have sprinkler system, they have sprinkler point on top of the chute, on top of the storage stations. So when the heat, the sprinkler point detect the heat, the sprinkler point will burst and put off the fire. So in Malaysia, what we do, we have two options here. One is actually to put a slide gate valve on top to isolate the fire, to isolate the storage station from the chute. And we also use actually the sprinkler point on top of the chute. So we can actually link this sprinkler point, the cleaning sprinkler point, to discharge the water, and then it will fall to the storage station and put off the fire. So at this moment, what we do actually is the first option by putting the slide gate valve and also the heat detector at the bottom of the chute, between the bottom of the chute and the storage stations. So we have provision there to be connected to heat detector or sprinkler point.
Understand. All right. We have another questions. This is asking about, so the AWCS utilize the vacuum system to push the waste towards the collection point. So the question is, what happens when the waste, which is small enough to damage the vacuum system, is also a seal system? So wouldn't the maintenance be harder?
Okay, the system actually is not in this way. Maybe maybe just now I didn't show correctly the waste flow direction, and also okay, the vacuum system suck the garbage through the container. So the waste will be trapped inside the container because the container have netting. So any small waste going through the vacuum exhauster, the centrifugal fan, the fan is robust enough to take all this small waste. It doesn't matter. So some fine waste going through the vacuum exhauster, the centrifugal fan, and to the air filtration system. The air filtration system will have the air filter, dust filter, and also carbon filter to filter off the smell. So the small waste doesn't damage the vacuum exhauster actually. Yeah.
All right. We have another question. Does the chute made just specially only for recyclable segregations?
Okay, in Malaysia, we don't encourage at this moment by putting two chutes, one for recyclable and one for non-recyclable. Usually, we actually recommend one chute only for non-recyclable. It's an option from we give an option to the client, architect and also developer to choose whether they want to go for stainless steel chute or they can also opt for concrete chute now, because system formwork now today provides quite a smooth surface finishings for inner side of the chute. So we have these two options. It all depend on the developer and architect. I'm not sure I answer these questions.
Okay. There's another question. What is the additional area required in a building to install the AWCS system?
I won't say additional area. Actually, I would say it's a smaller area, but every floor living room, it can be a smaller area now. Conventional system, you may probably need maybe 2 meter by 1.8 meter kind of space to house the MGB. This should actually what you need, the smallest size you need will be probably 1.2 by 1.5 meter, including the chute itself, because the chute is 500 mm. So another small area, for people to stand inside or maybe leave the recyclable or probably like maybe cardboard or newspaper on the floor for the cleaner to collect. So this is the every floor. And of course, the bin center, because now we have to house the vacuum system. Beside the bin, we have to house the vacuum system and the control panel. So the bin center will tend to be bigger, but we only need one in the entire development. So if you have maybe 6 or 7 blocks in development, you don't need to provide any block, one refuge chamber to store garbage, no more. So you can actually allocate one centralized bin center and remove the rest of the blocks, the ground floor, the refuge chamber. So in overall, you will still have a saving actually over there. The main central collection plant, the bin center. So it depends what is the size of this bin center. It depends on the generations. And the waste generation depends on how many units do you have in that particular development. If this is residential building, but if this is commercial building, then you depend on the net floor area of that commercial development to calculate the waste generations. Right?
So actually, in fact, it might be reduction of area instead of additional area required for the LWCS system.
Yeah, and in fact, you look at commercial building. If the conventional system, you had to design, a path, for the back of house path for the user, for cleaner to push the garbage, to the bin center. So by putting this system, you hang the pipe at the ceiling level. So the waste transportation horizontally will be at the high level. So it doesn't take any space at the floor level now. Yeah.
So we also have one question. What are the common maintenance required for these AWCS? What are the commonly issues faced with these AWCS?
All right. I think the common issues. Sorry, 2 questions.
Yeah, there are 2 questions here about common maintenance, and the other one is the commonly issue faced by the AWCS.
Common maintenance are usually we have actually quite a number of pneumatic parts because this is pneumatic controlled systems. So we have a pneumatic valve that we have to maintain. We have to visit, carry out preventive maintenance every month. So these are usually the moving parts. So we have to check the moving part whether there's wear and tear happening or not, and any vibrations. So these are very common that the technician will have to check every month. And then of course the filters. The filters will probably clog with the dust, or maybe the carbon filter is no more efficient. These are the common maintenance activities that the technician will have to perform every month. And of course, the vacuum exhauster will be probably every 6 months or every quarterly. So these are maintenance activities. Common issue that this system is facing today in Malaysia are more on the chute stockage. Because again, it's coming back to our attitude, because we tend to chuck everything into the chute. So, and this usually happen during vacant possessions. Why it happen during vacant possession? First, because there will be a lot of renovation works happening. So renovations, when it's happening, you will have some contractor, irresponsible renovation contractor, that chuck the cement or maybe a plasterboard into the system, because for convenient purpose, they just chuck inside there. So causing some issue over there. It shouldn't happen actually. So again, this one we have to manage with the management. Another issue is during vacant possession, we have the resident moving to the unit, to the new unit, to the new house, with all the stuff in the cupboard. So by then removing all this stuff from in their house, from the cupboard, the empty cupboard, they'll fold it to smaller piece. They throw it inside the chute, it expands. So when it expands, it's stuck at the chute. So what happened? Usually it doesn't cause any issue along the chute, but sometimes it's stuck in between. Then we have to go address it to clear the blockage. But it doesn't happen so regularly. Only the first 6 months of vacant possessions. If they're stuck over there, sometimes the garbage coming down from the top, you push the cupboard down, and eventually the blockage will happen at the bottom of the chute. So for may happen at the bottom of the shoe, the system will be able to recognize there's a blockage at the storage sessions. And our system is actually designed to interface with a website, this one program. So the system will send a telegram message to my technicians. So our control panel and control system will have a technician handphone number. So anything's happened, the system will automatically send the message to our technician to tell them there's an issue over there in this area. So we will be able to attend to it before the user realizes there's an issue in the systems. So these are a common issue that we are facing usually in the new systems.
I think that's all from the questions from the audience. So I think that's all the question from the audience. So on behalf of IGM Malaysia GBC, we would like to express our gratitude to our speaker today, Engineer Chia, and the fellow audience in the webinar. Malaysia GBC is a non-profit organization that promotes green building and sustainability. We are looking for more green industrial players like you to join us to grow the green economy. So we come to the end of the sessions. So we also like to inform that there are more webinars and events are preparing for you. Do log on the virtual igm.my to check the upcoming events. And also take the survey form, which will be emailed to you shortly. Kindly fill up the survey form and send back to us for further improvement. Okay, thank you so much, and I wish you all the safe and good health.
Thank you.
Thank you, Engineer Chia.
Thank you.
Thank you.